Standard 11 Chemistry, Unit 4, Chemical Bonding and Molecular Structure, Part 2. Here we discuss about the Lewis symbol. Valence electron. In the formation of the molecule, only the outermost cell electrons are taken part in a chemical combination is known as valence electron. For example, so fluorine and its atomic number is 9. Electronic configuration will be 1s2, 2s2 and 2p5. In outermost shell there are 2 plus 5, 7 electron. In 2s orbital this pair electron. In 2p orbital px, py and pz there are 5 electron, 1, 2, 3, 4 and 5. Here is the single electron or it is unpaired electron, and these 3 are paired electron. 2 plus 2 4 and 4 plus 2 6 electron, and the one single electron, total 7 electron. Here the symbolic representation is a single electron, and here the 3 paired electron 1, 2 and 3 symbolic representation, and this dot that represents the number of valence electron. Here for example sodium, its atomic number is 11, 1s2, 2s2, 2p6, 3s1. In outermost shell there is single electron, here sodium, and it is a single electron. Okay. Now for chlorine 17, its electronic configuration will be neon, 3s2, 3p5. There are 7 electrons in outermost shell, 2 plus 5, 7 electrons is the third cell. Now three, 4 and the fifth electron is 3p orbital and 3s orbital. Here in 3p orbital there is single electron. Here the chlorine is a single electron, and 1, 2 and 3 paired electron. Okay. Paired electron means there are 2 electrons, and the unpaired electron means here is 1 electron or single electron. Okay, in the outermost orbital. This is the symbolic representation, or it is named as Lewis symbol. Now the causal in relation to chemical bonding drew the attention to the following facts. The fact number 1, in the periodic table the highly electronegative halogens like fluorine, chlorine, bromine, iodine, or highly electropositive alkali metals like lithium, sodium, potassium, rubidium or cesium are separated by the noble gas. For example, here suppose fluorine and it has 7 electrons in the outermost cell. To complete its octets, it gains of 1 electron, and whenever it gains electron, it is converted to negative ion, or it is named as fluoride ion. Now its electronic configuration will be 1s2, 2s2 and 2p6. So it is as same as the neon, and neon is a noble gas. Here same thing is for the chlorine. Chlorine atom gains of 1 electron and it is converted to chloride ion, and its electronic configuration will be the same as the argon. Argon is a noble gas. Here in case of the sodium, there is single electron. To complete this octet, it loses 1 electron. Whenever it loses electron, it is converted to sodium ion. Now its electronic configuration will be as same as the neon, because it loses 1 electron in 1s2, 2s2 and 2p6. There are 10 electrons, and electronic configuration like neon, and it is the noble gases. This is the first concept. Now the second fact, the formation of negative ion from halogen atom. Halogen atom gains of 1 electron, it is converted to negative ion, and the positive ion from alkali metals. Alkali metals like sodium, it loses 1 electron and it is converted to positive ion. So it is associated with the gain or loss of electron by the respective atoms. The negative and the positive ion thus formed attain stable noble gas electronic configuration that we have already discussed. The noble gas is exception of helium. Why helium? Because here its atomic number is 2 and its electronic configuration will be 1s2, and it has only 2 electrons, so it is duplet of electron, have particularly stable outer shell configuration of the 8 electrons, and the rest of the electron here for argon, its atomic number is 18. So here neon 3s2, 3p6, so here ns2 and np6. There are 2 plus 6, 8 electrons. And the last is the negative and the positive ions are stabilized by electrostatic attraction. For example, here suppose sodium atom, it loses 1 electron and it is converted to sodium ion, and here chlorine atom, it gains of 1 electron and it is converted to chloride ion. The positive ion or the negative ion are stabilized by the electrostatic attraction. Here the sodium ion and the chloride ion is combined by the bond, and that bond is named as electrovalent bond or ionic bond. Here the bond formed as a result of the electrostatic attraction between positive and the negative ions is termed as electrovalent bond or ionic bond. Here the ionic bond or electrovalent bond. The ionic bond or electrovalent bond is formed by transfer of valence electron from one atom to the another atom. For example, here potassium and its atomic number is 19. Its electronic configuration will be argon 4s1. To complete its octet, it loses one electron and it is converted to potassium ion. Now it has 19 minus 1 electron, means here 18 electrons in electronic configuration like argon, and argon is noble gas. Chlorine, its atomic number is 17, electronic configuration neon 3s2 3p5. Here 2 plus 5 7 electrons. To complete this octet, it requires one electron, and these electrons will be transferred to the chlorine atom. While chlorine gains of one electron, it is converted to chloride ion. Now its electronic configuration will be neon 3s2 3p6. It's here 10 plus 8 electrons. Electronic configuration will be same as the argon. Here only the transfer of electron from one atom to the another atom. So potassium ion and the chloride ion is joined by the static attraction or the ionic bond is formed. Okay. Now this question is very most important, like explain ionic or electrovalent bond with example. Now the second concept is octet rule, and this rule is given by the Causal and the Lewis. According to this, atoms can combine either by transfer of valence electron from one atom to another. By transferring of electron, it forms ionic bond, or by sharing of valence electron in order to have octet. Octet means there are 8 electrons in outermost shell. have octet in their valence cell and is known as octet role. Is very most important for the 1 marks. Okay friends, so next time we will discuss about the covalent bond, which is formed by sharing of valence electron. Okay, thank you very much.